In this video, we will look at how we can add terms in index forms and simplify expressions like these. First, let's look at this expression. How can we simplify it? We know 2 cubed is 8 and 2 to the power of 4 is 16. We can add the numbers together to get 24. How about this expression with the variable x? We do not know the value of x. Does this mean that we cannot simplify this expression? Let's see. There is 2 to the power of x in both terms. If we represent 2 to the power of x as y, the expression will be 3y plus y. Now, can you see that these two terms contain the same variable, y, and are therefore like terms? So we can just add the terms 3y and y to get 4y. Since y is 2 to the power of x, we will have 4 times 2 to the power of x. Now let's try to simplify this expression. First, are these like terms? Yes, both terms contain 3 to the power of x. If we represent 3 to the power of x as y, we can add the two terms to get 7y. So we add the like terms to get 7 times 3 to the power of x. Next, can we do the same for this expression? First, are these two terms like terms? Well, they have different bases, so they are unlike terms. In other words, we cannot simplify this expression. Let's look at the examples again. These are like terms, and these are unlike terms. What do you notice? We can only simplify an expression when there are like terms. Now, how do we simplify this? Remember, we can simplify an expression only when there are like terms. So are these like terms? No, they are not. What then can we do? We can rewrite such that the two terms have the same base. We know 3 is a prime number, and 9 is a composite number, which can be expressed as a product of prime factors. We also know that 3 is a factor of 9, but can we express 9 as a power of 3? 9 is 3 times 3, or 3 squared, so 9 can be expressed as a power of 3. Now, how to simplify this? We can use this law of indices and multiply the indices and get 3 to the power of 2x. Now we can see the like terms. This means we can add 3 to the power of 2x to 3 to the power of 2x to get 2 times 3 to the power of 2x, and we write it like this. Next, let's look at this expression. How can we simplify it? We need to have like terms in order to simplify. Now, are these like terms? Again, they are not. The bases are the same, but the indices are not. What can we do? Well, we can try to express 5 to the power of x plus 1 as a product of index forms. Using this law of indices, we get 5 to the power of x times 5 to the power of 1. And 5 to the power of 1 is 5. By convention, we write constants on the left-hand side. So the expression is just 5 times 5 to the power of x plus 5 to the power of x. Now we can see the like terms. So we can add 5 times 5 to the power of x to 5 to the power of x to get 6 times 5 to the power of x. So, what have we learned? To add terms in index form, we need to have like terms in order to simplify the expression. Finally, let's apply what we have learned. How do we simplify this expression? Always check if they are like terms. Well, looks like there are no like terms. What can we do? We know 2 is the only prime number, and 2 is a common factor of 4 and 8. But can we express 4 and 8 as power of 2? Yes, 4 equals 2 times 2, or 2 squared, and 8 equals 2 times 2 times 2, or 2 cubed. How can we simplify these further? We can use this law of indices and multiply the indices. Now can you see that only these two are like terms? So we can add 2 to the power of 2x to 6 times 2 to the power of 2x to get 7 times 2 to the power of 2x. Now, these two are unlike terms, so the expression cannot be further simplified. Therefore, note that even if the index forms have the same base, it does not necessarily mean that we can reduce the expression to a single term.